we're going to look at characteristics of functions. So the first one we're going to pay attention to is domain. And for domain, we're just looking at our x values. Range is when we look at our y values. So for domain, we look and see where our function is starting, reading from left to right. So we can see that we've got this point right here, which is at -5, 4. And the x value that goes with it is -5. So our domain starts at -5. Since it actually reaches -5, it gets a bracket. Then we look to see where our function continues to. So we read from left to right and we see we've got this arrow. And that arrow means that it's continuing towards positive infinity. So our domain goes from -5 to positive infinity, and since we can't reach infinity, it gets a bracket. For range, we do the same thing, but now looking at our y value. So we start from the bottom and work our way up. Our lowest point is -2, -2. And the y value with that is -2. Since it reaches -2, it gets a bracket. And we go from the bottom all the way up, and we find our highest point, which is 1, 5. The y value with that is 5. Since it touches 5, it also gets a bracket. Now we're going to look at intervals of increase and decrease, and with these, we are using x values only. So you're breaking up your domain, and you're trying to figure out where on the domain is our function increasing and decreasing. So what I like to do is I like to draw lines everywhere it changes direction, where it begins, and all of that. And so we're going to highlight where it's increasing. And if you think about, again, you read from left to right, and if you think about an ant, where is that ant climbing uphill? So it's climbing uphill here. Let's make that smaller. Climbing uphill here and here. Where is it going downhill? Here and here. So we're going to break this up and write our intervals of increase and decrease. So where is it increasing from? And again, you're just using x values, and this is the reason why I draw the line, so we can look and see where those vertical lines cross the x-axis, because we need to use those values only. So it's increasing starting at x is -2, and this one keeps increasing where x is 1. And we're going to use brackets because it reaches both of those. Then we look at this next segment. It's going from 2 to 3. And we use the union symbol to separate them. Now we can look at intervals of decreasing. It's decreasing where x is -5 to where x is -2. And again, we can use brackets. And it's decreasing from where x is 1 to where x is 2. And then we're not going to use this section right here because it's neither increasing or decreasing. It's just a straight line going out. Because it's a straight line going out and it's not curving into a straight line, there are no asymptotes with this function. So there are no asymptotes. We see asymptotes when it's a curve going into a straight line. Since it basically has a sharp turn, that's why it doesn't have an asymptote. Asymptotes are curved lines going into a straight line. Now we're going to look at our relative, absolute, and absolute minimum and maximum. So let's start with our minimums. Our minimum starts. So for our minimums, we want to find our lowest, basically, dips in our graph. So we have a low dip here, which again is at -2, -2. And then we have another dip here at 2, 3. Absolute means it is the lowest point. So the lowest point is -2, -2. So this one's absolute. And then relative means that it is a low point on the graph, but it's not the lowest. So 2, 3 is our relative. We're going to do the same thing for our maximums. We have a maximum here at -5, 4. And then we also have another maximum here at 1, 5. And because we've got this line that keeps going, and it's also technically kind of like our maximum, both of these pieces are going to be relative because neither of them is the highest point on the graph because we have this other point that's at the same level as that one. So these are both going to be relative. Last thing we're going to look at with this graph is our zeros, which are also your x-intercepts. So where does our function cross the x-axis? It crosses here where x is -1. And we just use parentheses because we're just talking about a point on the graph. And at -3, so -3, 0. And our y-intercepts is where it crosses the y-axis, and it's in between 2 and 3, so it's about 2.5. So it's 0, 2.5. Now we're going to look at average rate of change, and we're going to still use that function before. So once the average rate of change over the interval -4, 2. And the ones that they're giving us are our x values. So we want to find where x is -4 and find that point. So x is -4, where y is 2. And then do the same thing with the 2, and we already know that that's 2, 3. So we're going to find the average rate of change between these 2 points. When we do this, we're going to use it's the same thing as our slope formula. So it's y2 minus y1 over x2 minus x1. And again, those points are -4, 2, and 2, 3. From here, we're just going to sub these values in. So it doesn't matter which point we make point 1, which one we make point 2. Just make sure that your y2 and x2 are from the same point. So y2, let's go with -3. So 2 will be x2. This 2 is y1, and -4 is x1. So y2 is 3, minus y1 is 2, x2 is 2, and x1 is a -4. 3 minus 2 is 1, and negative of a negative makes it positive, so 2 plus 4 is 6. So our average rate of change on the interval -4 to 2 is 1/6. The next one, it says write the equation of the parent quadratic function that has been stretched by a factor of 3, and shifted right 2. The quadratic parent function is x squared. What gives it that stretch is the number in front of x squared. So multiplying a number times x squared. So we're going to put a 3 out in front. And then shifting right 2. This goes in parentheses with our x value. So right now we have 3x, and then we need something inside the parentheses with the x. And we're going right 2. Well, our transformation function is x minus h squared. So we've got to change the sign. So right means +2, but we've got to change that sign of the +2 and make it a -2. So this function right here will shift our parent graph, which is x squared, it'll make it stretched by 3 and shifted right 2. It's always the opposite of what you think it would be inside the parentheses. For this next one, the graph ended up being on the other page. So we're going to perform the transformation on this next page. And again, the function for this, the transformation, is -1/2 the function x plus 2 plus 3. And this should be 1/2 h. All right, so I recommend breaking this down into different parts. So the first thing that we can see here is that we're going to go up 3. And we're also going to, again, we're going to change the sign of this. So it's going to be a -2. So we're going to go left 2. This negative means we're going to reflect. And this 1/2 means we're going to shrink by 1/2. So I recommend doing the reflection first and then the shrink, and then we can move it left, right, up, and down from there. So I'm going to use different colors with this. So when we reflect, these points are going to be in the exact same spot, just on the other side of the x-axis. So for this one, we have -5 up 4, so we're going to do -5 down 4. This is -2, -2, we're making -2, +2. +1 up 5, +1 down 5. +2 up 3, +2 down 3. And then we have 3 up 5, and we know that this is a straight line. Then we can connect our dots or our points. So there's our reflection. Now we want to shrink this. For this, we're going to half the distance from our x-axis for each of these points. So half of this part right here is down 4. We're going to make it down 2. Half of this section, it went up 2, so we're going to go up 1. Here it's down 5. We're going to go down 2.5. Down 3, we're going to go down 1.5. And again, down 5 again, down 2.5. And over. So we're going to connect all these points. So we shrunk it vertically. And then we're going to take all these points and we're going to go left 2, up 3. So -2 with our x values, +3 with our y values. So let's get another color. And we're going to take this point, which is -5, -2. And we're going to subtract 2 from it and add 3, which gives us a -7, +1. So -7, +1. This next point, we have -2, 1. We're going to subtract 2, add 3. So -2 and 2 is 0. 1 plus 3 is 4. So 0. Sorry, -4, +4. -4, +4. For here we have 1, -2.5. So again, we're going to subtract 2, add 3, which gives us a -1 and 0.5. -1, 0.5. We can go ahead and start connecting. Then we have 2, 1.5. It's negative. So add a -2, which is 0, and 3, which is 1.5. 0, 1.5. And 3, negative 2.5, subtract 2, and add 3. We get a positive 1 and a negative 0.5. And then we go over. So that's how we do transformations of functions. For this next one, we again have a reflection. Now we have a stretch of 2. Again, change the sign of this negative, make it positive 1. So we're going right 1 and up 3. So this is positive 1, positive 3. So let's start with our reflection first. When it's on the x-axis, it's not going to go anywhere. So we only have a few points to mess with. So we've got right here, it's going up 2, so we're going to make it go down 2. It's going down 1, so we're going up 1. And then again, it's back on the x-axis. So we're going to do the same thing, but we're going to break it in half. So instead of going up 2, we're only going up, we're doing a stretch. So instead of going up 2, we're going to go up 4, or down 4. Instead of going up 1, we're going to go up 2. And then we end up back on our x-axis. Next, we want to move these points right 1, up 3. So for this one, we're going to move this point right 1, up 1, 2, 3. We're now going to move this point right 1, up 1, 2, 3. Connect them. We look at this point right here. We're going to want to go over 1, up 1, 2, 3. Same with this one. You want to go over 1, up 1, 2, 3. And then back on our x-axis, we go right 1, up 1, 2, 3. And it should look the same thing as this turquoise line. It's just shifted to the right 1 and up 3. And it should be congruent to that. For this next one, we want to know how the graph of the function y equals x squared plus 4 would be affected if we changed it to x squared plus 1. So the only thing that's changing on this is what's added to the function. And 4 minus 1 is 3, so it's going down 3. And that's all that's happening, because when we add a value to our function, it changes how high and low the function goes. So it's just going down 3. For this one, we want to know if the function is even, odd, or neither, and we can graph it. And I went on Desmos.com, and I graphed it. And this is what the function looks like. When it's even, that means that I can break it down the x-axis and fold it in half, and it looks the exact same. So this one is not even. Let's see if it is odd. Odd means that when I rotate this graph 180 degrees, it looks the exact same. Well, it would. The only issue is that it is not on the origin. So when we rotate it, this is now up here. So it is also not odd. So this one is neither. Here we're looking at the average rate of change over the interval 1/6. And I'm using Desmos to graph the function so that we can actually look at this, and that's actually supposed to be up here, 1/6. So when we look at Desmos, we can see where x is 1 and where x is 6. And we're going to use our y2 minus y1 over x2 minus x1 formula. So we just go to Desmos and we look and see where those points are in the function. So where x is 1, the function goes down to -4. Where x is 6, the function goes down to where x is -5. So we can just put this into our average rate of change formula. We have -5 minus a -4 and a +6 minus 1. Negative and a negative makes it positive, so -5 plus 4 is -1. 6 minus 1 is 5. So our average rate of change on those intervals from 1 to 6 is -1/5. Then we're going to do the same thing for our domain of our function. We're going to graph it into Desmos and see where it is. When you graph this into Desmos, you're going to see that you have this line approaching x equals -4, and this line approaches. So we actually have an asymptote here where x is 4. So an asymptote where its x is 4. So our domain is going to be split right there. So we have this function goes all the way to -infinity, but it's approaching 4 and never touches 4, so it gets a parentheses. Then this piece of the function picks up back at 4, again not touching, and goes all the way to +infinity. So the domain of our function is -infinity to 4 and 4 to infinity. And again, it gets brackets because we have an asymptote, meaning our function gets closer and closer to 4, but never touches it. Then we have the domain of x minus 1 plus 2. For range, we're going to look and see where the lowest point is. So our lowest point is right here, where y is 2. So it's starting where y is 2, and then it keeps on going all the way to +infinity. Infinity always gets a parentheses because we can't reach it, and since it starts at 2 and it's got that solid point there, 2 gets a bracket for the range. When we're asked to evaluate, and so they give us a function and they give us a number to substitute in, we're just going to take that -3 and sub it in for anywhere we see an x. So we're going to rewrite this negative in parentheses -3 squared minus 6 parentheses -3 plus 3. Always use parentheses because that'll help you when you're doing this. -3 squared is 9, so we're going to bring down this negative. -3 squared is 9. -6 times -3 gives us a +18, and then we add the 3. So -9 plus 18 is +9 plus 3 gives us 12. So when we evaluate the function, we get 12. To find zeros of a function, your zeros are the same thing as x-intercepts, solutions, and roots. So if you have a function, when you look at the graph, all you're doing is looking to see where it crosses the x-axis, and that'll give you your zeros of a function. Now we're going to look at f of x equals 1/2 absolute value x minus 2 minus 5. And what you need to do is just pick some x values. And I like to start with either -2 or -3. And you're just going to sub these values in for x into the function. So we have 1/2 -3 minus 2 minus 5. So -3 minus 2 is 5, and it's -5, but since we're taking the absolute value, it is a +5. Half of 5 is 2.5, and then we subtract 5, which gives us a -2.5. So we go over 1, 2, 3, and down to 0.5. Do the same thing with negative 2. 1/2, absolute value, negative 2, minus 2, minus 5. Negative 2 and negative 2 makes it a negative 4, but since we're taking the absolute value, it becomes positive. Half of that is 2. 2 minus 5 gives us negative 3. So negative 2, negative 3. 1/2, negative 1, minus 2, minus 5, we get negative 3. Half of 3 is 1.5, minus 5 gives us negative 3.5. So our x value is negative 1, y is negative 3.5. And then we'll do 0. 0 minus 2, negative 5, we get negative 2, which becomes a positive 2 with absolute value. Half of 2 is 1, so we get negative 1, absolute value is positive 1. And 1 minus 5 is 4. So we get negative 4. 0, negative 4. Then we do the same thing. 1/2. 1 minus 2 gives us a negative 1, which becomes a positive 1. And half of 1 is 0.5. And we subtract our 5. And you get negative 4.5. With 2, 2 minus 2 is 0. Half of 0 is 0, minus 5, and we get negative 5. Then we can do 1/2. 3 minus 2 is 1. Half of 1 is 0.5. Minus 5 is negative 4.5. So 3, negative 4.5. And you can actually start to see where the absolute value is going to start going back up. And that's how we graph the function using a table. So again, we're going to pick some values, negative 2, negative 1, 0, 1, 2, 3. And we're going to sub them into our functions. We have negative 2 plus 7 squared minus 6. Negative 2 plus 7 is 5. 5 squared is 25. Minus 6 is 19. Negative 1 plus 7 is 6. 6 squared is 36. Minus 6 is 30. 0 plus 7 squared is 7. Minus 6, we can see that it's going up. So we need to actually go back and find some lower values. And this is what we do when we graph by a table. Sometimes we pick some values and if they become too high. So we want to pick lower than those values. So I'm going to pick, let's say, negative 7, negative 6, negative 5, negative 3, negative 2. So we have negative 7 plus 7 squared minus 6. We get 0 and a negative 6. Negative 6 plus 7 is 1. 1 squared minus 6 is negative 5. Negative 5 plus 7 squared. We get 2 squared, which is 4. Minus 6 is negative 2. This should be negative 4. So we have negative 4 plus 7 squared minus 6. 3 squared is 9 minus 6 is negative 3. Excuse me, positive 3. Negative 3 plus 7 is 4. 4 squared is 16 minus 6 is 10. And then we're back to where we started on the other one. Negative 2 plus 7 is 5. 25 minus 6 gives us 19. So we can graph our function. We graph negative 7, negative 6, 2, 3, 4, 5, 6, 7, negative 6, negative 6, negative 5, negative 5, -2, -4, 3, -3, 10. We can see that we got our quadratic function going up this way. That means that this is our vertex, and it's going to go up this way on the other side. But we can graph it based on what we've got here. This gives us enough to see how the function's going to look. For this one, it's just like what we did in number 19. All we're going to do is sub 17 and for x into the function. So we have -4 times 17 plus 52. And when we do that, -4 times 17, we get -68 plus 52 gives us -16. Last one, we're going to look at the graph of the function, and it's on the next. So the function is -1/2 x plus 2 plus 4. This combines what we did with number 21 and what we did for the first few questions. So I'm just going to briefly go over how you would approach this one. I'm not going to actually do this one. Again, do your T-chart. So we've got our X workspace and our Y values. Pick some X values. So you could do, think about when you put, say if we started with -3, -3 plus 2 is -1. Half of that, and then adding 4, it should work out. So we got -3, -2, -1, 0, 1, 2, 3. So when you get -3, you're gonna get 3.5 and continue going. From there, you'll look at the graph and figure out what all this stuff is. Parent function though is basically, we know we have, based on our transformations, we've got a reflection here, shrink, move left 2, and up 4. So our parent function is everything but these pieces. So it's just the absolute value of x. So once you graph it, you can find the domain, range, intervals of increase and decrease, minimums, maximums, zeros, and then we just briefly talked over your transformations of the parent function. Page here, and the function